Hello everyone, how are you doing? Welcome to week 11 for Practical Math B. This is our last official lesson for the second semester. We're going to be looking at profit maximization. So here's our essential question. How can we use calculus and graphing tools to determine the level of output to maximize profits for a business? All right, hopefully calculus is not making you quake. We've already touched a little bit on it. We got some good stuff. I'm excited to get into this lesson. Here's what we're going to be learning. We're going to talk about defining diminishing marginal returns, marginal cost, marginal revenue. We've worked a lot with marginal so far this semester. Also looking at profits, profit maximization, costs, and revenue. We're going to do a quadratic function based on a firm's demand. We're going to build a profit function based on the total revenue and total cost. And we're going to determine the maximum of the profit function. So this is basically essentially an optimization problem to determine what quantity of output maximizes the profits. We're going to use some calculus to help us get there. Take notes, pause this video at any time. Again, there's some good examples that I'll be using, and the examples, you're pretty much going to see questions based off the examples in the lesson quiz. So use this video, use the week 11 text as a resource while you're working on all the other assignments this week. All right, so Apple. You guys all know Apple computers, right? Many of you may even have an iPhone. But Apple company is by some arguments the most successful company over the last 20 years in terms of computers, iPhones, and iPads, all the other tech gadgets that they make. However, as a company, they're still very much concerned about how much revenue they bring in from selling computers and iPhones, as well as how much it costs to produce and sell all their tech items. When we talk about profit, profit is the total revenue from a company's sales minus the cost of production. Let's take a look at Apple's quarterly earnings press release and just start to dig into some of what they have going on. All right, here we go. So Apple reports first quarter results. What does that mean? Well, this is an article from January 27th, 2014. And when they talk about the first quarter, they're talking about 3 months ending in December 28th. So October, November, December, those 3 months, and looking at, well, what happened in terms of the business over the 3 months. So let's take a look at some notes. The company, Apple, posted record quarterly revenue of $57.6 billion. All right, so we got the word revenue. That means everything they sold, and again, that's the holiday season, this is big news, they sold 57.6 billion things. That's how much people paid for the iPad, the iPhone, the earbuds, all the other stuff that they make. Now, after that, though, that's revenue, all the sales, right? But their quarterly net profit was 13.1 billion. Remember, profit is how much revenue they get minus all the costs. So if we do a simple subtraction problem, we can start to see, wow, they made a lot of money coming in, but it cost a lot. But they still profited 13.1 billion. That's pretty good, right? Or 14.50 per diluted share. Now we're getting into a little bit of stocks here. The results compare to revenue of 54.5 billion. So before that, again, if we look at not October, November, December, but if we look at July, August, September, the 3 months before, that earlier quarter, they sold a little bit less, right? They only sold 54.5 billion in revenue, so that's a little bit less. But look at that, their profit was still the same. They still made 13.1 billion. So here and now we're starting to get into this. Even though Apple sold more, they sold 3 billion more items, they didn't make any more money than they did the previous quarter. So that's interesting. This is where the whole idea of, well, how much should we make to make the most profit? Apparently making more didn't profit anymore for Apple. All right, let's scroll down a little bit more. Again, I'll post this in this week's module if you want to read it more carefully. But here's some interesting numbers down here. Here you can see on December 28th, 2013, compared to the quarter the year before in 2012, You can see there's their net sales. So they had 57.6 billion. That's how much they sold. Compared to the year before, they sold 54.5 billion. So they're selling more. Things look better, right? You're selling more iPhones. Everyone's happy. The cost of the sales, even though they sold more, things costed more, right? It costs a lot of money to sell stuff. So the gross margin just tells you, well, after your costs, how much did you make? And here you can see that, well, kind of about the same amount. So even though they sold 3 billion more from the previous year, their overall costs were about 800 million. So not as much as you think they would. But then here's they have to account for operating expenses, so there's more costs, research and development, selling and general and administrative, so more costs. So we subtract these costs down, and now we've only made 17.46 million and 17.2. This is pretty much identical numbers. This is their operating income after we take away costs. Now they get some other income and other stuff going here, but look at that. When it's all said and done, even though they increased the amount of revenue, they sold a lot more, their profit was exactly the same. So let's go back to our PowerPoint and start to summarize some of these things here now. So for Apple, in the first quarter, the first 3 months of 2014, they had a total revenue of $57.6 billion. We saw that. But their total costs were $44.5 billion when we added all those different expenses, research items, sales, etc. So their profits for that quarter were $13.1 billion. Now shareholders, this is where what's important, right? There's stuff at stake. They need to get a profit. Shareholders ended up getting a dividend of $3.05 or $3.05 per share from the profits. So Apple not only wants to sell iPhones and computers and all this other stuff, and not only does it want to have more people using the product, they need to make money. People investing in Apple, all the shareholders are expecting to get dividends. They want to see profits because that means they're going to make money off of investing in Apple, all the stocks, everything we've done, talked about stocks in terms of the previous week. So if Apple sold a lot but had no profits means the shareholders get no dividends. And if the shareholders are not happy, they will sell their stock and buy other stock. And if they start selling their stock, then Apple starts to lose investments and lose income, and it's no good. So, earning the most profit possible is important for companies. That's what we want to do. Let's use some math to help us figure that out. So let's watch a short video just to get refreshed and just to get more into this idea about revenues, costs, and profits.
A business's profit is the difference between the total revenues it receives from selling goods and services and the total costs associated with producing and selling those goods and services. Let's use the example of a company producing freshly squeezed orange juice. How does this company earn revenue? Selling the orange juice it makes, right? Let's say that the company sells its orange juice at $50 per case, and in a given month the company sells 1,000 cases. How much revenue did the company generate that month? That is correct. So is $50,000 the profit the company earned for the month? Right. Based upon the following monthly costs, what is the profit the business earned for the month? You might want to grab a piece of scratch paper. That is correct. Multiplying the materials and labor costs of producing a case of juice by the 1,000 cases sold yields material and labor cost totals of $10,000 and $5,000. Adding on $5,000 for factory rent, $1,000 for utilities expenses, and $14,000 for non-production employee salaries, we get total expenses of $35,000. Total revenues of $50,000 minus total expenses of $35,000 equals a profit of $15,000. The profit that we just calculated is called accounting profit. When economists talk about profit, they are usually talking about economic profit. This is because only economic profits change how resources are allocated. The costs shown here are called explicit costs. Economists are also interested in what are called implicit costs. Implicit costs include the monetary income a firm could have earned by using its resources, including entrepreneurship, in their best alternate use. In this example, the orange juice producer's implicit costs are $10,000. That results in total costs of $45,000 and an economic profit of $5,000. All businesses strive for profits. Profits are the reward for identifying and satisfying a consumer want. Economic profits also influence how resources are allocated. In a market system, profitability is a major factor influencing what type of business an entrepreneur starts. If significantly more money, beyond normal profits, could be made renting video games than making and selling orange juice, the business owner might decide to close the juice factory and start a video game rental service.
All right, so we talked about profit maximization. It gets us into this idea, now switching gears and thinking about math. Math is concerned, or a branch of math is about optimization. Optimization is using math to help us find the best and most efficient way to do something. We use optimization a lot. In airport scheduling and flights, they use math to make sure how do we get the most passengers in the least amount of planes and flying the least amount of destinations to use the least amount of gas. There's a lot of math involved in getting all that right. Shipping companies use a lot of math in terms of shipping goods from one place to the next in the fastest way possible, using the least amount of shipping time and gas and resources. Engineering design uses optimization to make efficient buildings. Road building and infrastructure in terms of maintaining roads, fixing roads, building roads. And finally, in economics, we use math and optimization a lot to make sure we're selling and producing at the best and most efficient way possible. So, since profit equals total revenue minus total cost, we're going to use some math. We're going to use functions to represent the total revenue. We're going to use a function to represent the total cost. And ultimately, we're going to use subtraction of my two functions to make a profit function. Again, I'm kind of helping you where we're going to go. So when we start doing this example, it's going to make sense. Once we have a profit function, we can then use our graphing abilities in our Desmos calculator and a little bit of calculus to help us determine the amount of production our company should have to get the maximum amount of profit. All right, that's what we're going to be doing. Let's go ahead and get into it. So here's some of the economics we're going to be doing. Again, this is kind of a big summary of all that we've been learning. We're going to talk about supply and demand and how that quantity and price are affected. We're going to talk about marginal cost and marginal revenue. We're going to talk about the law of diminishing returns, as well as fixed and variable costs. All right, are you ready to start thinking like a mathematician? First, let's start with a hypothetical price function of a good. We know from way back earlier in this class that supply and demand, that if we increase the price of a product, if we make it more expensive, people don't want to buy it. The demand for that product decreases. If we make something cheaper, people want to buy it. It's cheaper. The demand increases. So this is called an inverse relationship, and we're going to use a linear function to represent that. So there we go. Price is equal to 10 minus Q. What does that mean? Well, it means if we make the price at, let's make it $8. Well, the quantity then, $8 equals 10 minus Q. And if we solve it out for Q, I'm going to add Q to both sides. I'm going to subtract 8 from both sides. We can see that the quantity then would equal 2,000. In this case, quantity is going to be 2. If I made the price less, if I made the price only $3, how much would my quantity be? So now we have 10 minus quantity. Well, if I solve this one out, I can see that the quantity is going to actually equal 7. So if I lower the price, the quantity increases. Let's take a look at what that looks like on a graph. Here you go. There's some points on there. If I increase the quantity, that's my x-axis, quantity of items in thousands, it's going to fluctuate the price of this. So this point right here represents producing 4,000 items. That's how much I'm going to sell at $6 for each item. If I lower the cost, if I make 7,000 items, that's what that 7 represents, and sell it for $3, there's going to be people that want to buy that. If I made only 2,000 items, there's only enough demand for $8 each item. So you can see there's price and there's how much to produce and the demand based on different price points. All right, so we have a function for price. Let's now get into the total revenue. How much do I make when I sell my items? So simply put, the money you make as a business is found by multiplying the quantity of products sold by the price at which you sell the product. So we have a function showing how the price, there we go. There's total revenue equals the price times how much I sell. If I sell 1,000 things at $1, my revenue is going to be $1,000. But it's not as simple because remember our price and quantity vary. We have fluctuates, right? It's not locked in. So we have an equation that represents the price. So I need to do a little bit of substitution now. I'm going to say, okay, the price is equal to all this. It's an inverse relationship. But my total revenue, TR, is equal to the price times Q. Let's substitute price, P equals 10 minus Q in place of price, and we get a new function. The total revenue is equal to the varying price, which depends on how much I produce and the demand, times the quantity. If I do a little bit of distribution here, we get total revenue equals 10 times Q minus Q squared. We have ourselves a quadratic function, right? Anything times we have a variable squared, we have a quadratic function. Remember what quadratic functions look like? We've done some review of that over the last few weeks. Let's take a look at the graph now of my total revenue function. There we are. There's a parabola, right? That's a quadratic formula or quadratic equation always gives me a parabola. And what do we have going on? Well, again, my quantity sold, how many items I sell is along the bottom in thousands. So there's selling 2,000, 4,000, 6,000, 8,000 items. And my total revenue now is, remember that price changes. So as the price changes, I make more money. So if we sell, now why is it curved like this? That's a good question. Remember how if we sell less, the price was higher. But if we sold more, the price was lower. So I can sell a whole bunch of items, but it's going to be so cheap to be able to sell that many items that I'm not really going to make that much money. Similarly, I could sell a few items for a very high price, but I'm not going to sell as much. So looking at this, it seems like if I sell 5,000 items, which would end up being $5 per item, right? 10 minus 5, using my price equation, I would get a maximum revenue. There's a maximum revenue of $25,000. So looking at just revenue alone, I would say, oh, I want to make 5,000 items. That's the best price point to make the most items and to make the most money, right? And it's true. I would get the most revenue for producing and selling that many items. All right, there's revenue. That's how much money we're bringing in as a business. Unfortunately, I also have costs. I need to consider how much it costs to make things and produce things and to sell things. So to figure out the costs, businesses need to calculate both the variable and fixed costs. Remember, some things are fixed, like rental space or production tools. Variable items could be how many resources I have, increase the amount of resources, increase the amount of workers. Remember in the example of Apple, they had to spend money on advertising, selling, research, production, and other costs, right? We saw that on the Apple quarterly earnings sheet. So we have to remember this idea about the concept of diminishing marginal returns, and that initially we can produce more at a lower marginal cost, but as we keep increasing the amount of variables, there's a point where trying to produce more ends up being really more expensive. Remember that example of having 20 workers trying to work with only one pizza oven? There's a point where making pizzas gets efficient, and then there's a point where too many workers actually makes it cost more. So we're going to represent our total cost function with a polynomial. And there it is right there. Look at that, big business. Total cost equals 2 times Q cubed. Again, Q is my quantity produced or quantity sold. So the more I produce, it's going to affect my total cost, right? Minus 4 times Q squared plus 4Q plus 4. This is a third degree polynomial. Let's take a look at what it looks like on a graph. It'll help give us some more sense of it. All right, what do we have? Well, we can see that as I produce more and sell more goods, right? Again, on the bottom is still my quantity sold. As I produce and sell more, it's going to affect the total costs in thousands of dollars. The cost increases, but not much, and eventually it kind of slows down, and I can make more, and it doesn't really cost more, right? Except until I get to this point here, which we call an inflection point, right? It kind of curves opening down, but now here it starts to curve the other way. After 1, it starts to slowly increase, and now the costs are increased, and now they're spiraling out of control, and now to produce and make just a little bit more shoots the costs way up high. So you can see there's a point in which my costs are kind of stable, and I can increase production, but then there's a point where trying to produce a little bit more is going to make it cost a whole lot more. So I need to use this function to balance with my revenue to try and figure out, well, what is the best selling point? How much should I make in terms of balancing revenue and costs? So now we can build our profit function. Remember, profit is simply how much money you make minus how much money it costs to make those things. So it's just a simple subtraction. But we have a function for my revenue, and we have another function for my costs, and we just simply need to subtract my 2 polynomials. So now we're going to do some review on polynomial subtraction. We've done that in terms of our algebra review this term. So let's take 10q minus q squared. I'm going to take that polynomial, and I'm going to subtract off my cost polynomial, 2q cubed minus 4q squared plus 4q plus 4. If I do my polynomial subtraction, I need to distribute the negative sign. So really it becomes 10q minus q squared minus 2q cubed plus minus gives me plus 4q squared minus 4q minus 4. And now we organize and put them into descending orders. So the largest one is this one right here. I'm going to switch colors to make it a little less confusing. So we have a negative 2q cubed. I'm going to put that first. I want the largest power of q first. My next one is I have a minus q squared plus 4q squared. So minus 1 plus 4 is going to give me plus 3q squared. Then I have a 10q minus a 4q, so that net effect is plus 6q. And then at the very end I have a minus 4. So there is now my profit function. This is one function that's going to take into account both how much money I make when I sell a certain amount of quantity and how much money it costs when I produce a certain amount of quantity. Notice my variable is still Q. That's how many items I'm going to sell. So I have a function that says put in a number of items to sell and we'll tell you how much money you'll make for selling that number of items. So I could put, I could sell, let's say, put 1 in for 1,000, or I could put, what if I sell 3 for 3,000 items, or what if I put 100, what if I sell 100,000 items. So I could put different amounts of Q and see how much money I'm going to make for selling those different values. But let's just jump right to a graph, right? A graph is a great way to see all the different values and to get a good sense of what this function is doing. All right, so what do we have going on here? We have a lot going on. First of all, there's my revenue function. Remember that first parabola we did? So this blue line is telling me, based on how much you sell, how much money I'm going to make. So again, if I sell, let's pick a good value. If I sell 2,000 items, according to my revenue function, I will bring in 10, 12, 14, $16,000 in revenue. But I also have my cost function right here. Remember that third degree polynomial? It kind of increased, decreased, and then increased again. And this one is telling me, well, based on certain things, it's going to cost a certain amount. So say if I sell 2,000 items, I'm going to make $16,000, but it's going to cost right here. See, that was $16,000. It's going to cost $12,000. So $16,000 minus $12,000 cost, revenue minus cost means I'll have a profit of $4,000. So you can see how all three of these functions are related. 16 minus 12 gives me 4. This black line represents the profit. Now, as a company, I want to make the maximum amount of profit. I don't want to make too many goods and accidentally sell stuff. Remember with our revenue, we talked about how we could sell 5,000 items and we would make the most amount of money. But watch what happens if you even do 3,000. If I do 3,000 items, I will make a little bit more, right? I will make about $20,500. Right, reading that point right there, a little bit over $20,000, which seems good, right? I'm making more money. Let's go from 16,000 to 20,500. But unfortunately, I forgot about my costs. My costs are way up here at like 34,000 approximately. That's bad news, right? Even though I've made more revenue, my costs are out of control. I've lost money. My profit is in the negative. We lost $14,000. Think my shareholders are going to be happy about that, about losing profits? No, there's a point where I don't want to make too much. I want to make just enough to balance the costs, to balance the revenue, and make the most amount of profit. Well, that is going to happen when this profit curve is at its highest point. So looking at its maximum value, I would say it's right around here somewhere, right? So there's where my maximum profits are going to happen. And just estimating off of my graph, that's about 1, 2, 4, 1, 2, 3, 4, 1.5. It's going to happen about 1.6. So it looks like, according to this, when I sell 1.6 or 1,600, remember my x-axis, when I sell 1,600 items, that's right there. Oh, that's how many quantities sold. If I sell that many, now I need to find my y value. It's going to be roughly around here, 0, 2, 4, 6, 8, 10. So that's right in between 4 and 6. I'm just going to estimate 5. If I sell 1,600 items, my profit will be $5,000. Remember, the y-axis is also in thousands of dollars as well. So that's pretty good. It's more than this 4,000 right here. It's way better than losing money. So apparently, I now have a goal. I now have an idea as a business in that I need to make and sell this many items, and I'll end up making that amount of money. I've got math to help me figure out all this decision making. So there we go. Let's summarize what we did. When we looked at the profit function, it seemed like the maximum value happened when we produced 1.6 thousand items, or 1,600 items, and we had a profit of around $5,000. Now, that was just approximating off of a graph. We can use calculus to actually help us find it exactly. Now, we've done a little bit of calculus. What we're going to do is just find the first derivative. I'll show you how to do that of our profit function. We're just going to, again, work with the profit function. The derivative is really related to slope. So we're just simply finding when does the slope go from increasing to decreasing, and that point right when it's 0 is the maximum point. So we're going to use the first derivative to kind of find the best slope, and then we're going to solve that derivative when it's equal to 0. And then that'll give us the quantity to produce the maximum profits. So here we go. Take good notes on this on a piece of paper, and let's solve this one out. First of all, let's find the derivative. Let me use blue, feeling blue right now. The derivative, we use the power function by taking each term separately, and I multiply the power by the coefficient and then reduce the power by 1. So the derivative of the profit, we put a little mark for the derivative, is 3 times negative 2, which is going to be negative 6 times q squared. There's the first term. Plus 2 times 3 is going to give me 6 times q. Instead of the second power is to the first power now. Plus 6. There's a 1 right there, so 6 times 1 gives me 6. And q dropping down that 1 power just means q goes away, and then I forget the negative 4. So there is my derivative function. This function is going to help me find when is my function increasing, and when is it stop, and when does it start to decrease. Essentially gives me the slope at any point that I want for this function. All right, so now I need to know when does the slope equal 0. If it's positive, that means my profit is still increasing. If it's negative, my profit is decreasing. So a slope of 0 means my profit is at its highest possible point and it's not increasing or decreasing. So when does that equal 0? Well, I just set my function. When does negative 6q squared plus 6 times q plus 6, when does it equal 0? We're going to find the value for quantity. How much should I produce to get the maximum possible? Well, this is a quadratic equation right here, right? I have a value for A is negative 6. That's the coefficient. My value for B is 6. We've reviewed quadratic equations and the quadratic formula in the last few weeks. And my value for C is 6 as well. And we can use my quadratic formula. So let me switch colors here. The quadratic formula will give me the quantity to produce. It's going to solve for Q is equal to negative B. So I need to have negative 6 plus or minus the square root of B squared. So that's 6 squared minus 4 times A. A is negative 6 times C, which is also positive 6. And this whole thing is divided by 2 times A, or 2 times negative 6. So we're using our quadratic formula because that's what we use to solve when quadratic equations equal 0. If I do some simplification, everything in here, 6 squared minus 4 times negative 6 times 6, all that equals 180. So now we have negative 6 plus or minus the square root of 180 over negative 12. Now let's take the square root of 180 and we get negative 6 plus or minus 13, I'm going to go ahead and round it to the nearest thousandth, 13.416 divided by negative 12. And now if we think about this, right, a negative divided by a negative turns into a positive number. I'm trying to find out how much to produce, right? So I don't want a negative number. If I do negative 6 plus 13.46, negative 6 plus 13.416 divided by negative 12, that equals a negative number. And I don't really care about that solution. I'm not going to make a negative a number of things, so I only want the positive case. So let's ignore that one. Let's find out when does negative 6 minus, that's the other case, remember, plus or minus, negative 6 minus 13.416, subtract those, and then divide by negative 12, and what do we get? Well, we get 1.618. So we need to sell or produce 1.618 items. Or it's actually 1,618 items. Remember, it's in thousands. That was pretty close to what we did, right? Remember, we estimated from our graph 1.6, and really in exact, it's 1.618 or 1,618 items. All right. I'm liking that, feeling good about it. Our math is matching up with what we've visually seen in our graph. So now I know how many items to produce. Well, how much money am I going to make? Again, this is a profit maximization. So I want to know, well, how much profit is that going to give me? So now we need to do the next step. If we sell, so basically we saw that my Q, the quantity I need to sell is 1.618 items. My next step is to actually calculate the product. And what I do here is I just simply take 1.618, put it in for Q, and I calculate the polynomial out. My profit will equal negative 2 times 1.618 cubed plus 3 times 1.618. The nice thing about having a mathematical function is that I can simply put numbers in. I'm putting in Q to find out what P should be. Plus 6 times 1.618 minus 4. To help us calculate this out, let's just go directly to our Desmos calculator and do the math on there. All right, here we are. We're going to calculate our profit function. So let's put in all the numbers we had. We had negative 2 times 1.618, close parentheses. To the power, I can either do this little AB here, or I can do shift 6, but we're going to do that to the third power, plus 3 times 1.618 to the second power, plus 6 times 1.618 minus 4. And what do we get? We get 5.0901. I can keep going on, but let's call it 5.09. That's my profit right there. That's my maximum amount of profits. So if I produce 1.618 or 1,618 items, I'm going to get a maximum profit of 5.090 or $5,090. Nice stuff, right? Again, using our Desmos calculator, using math to help us figure out the best possible way to go. So what did we find? We found that when we produce and sell 1,618 items, that was the most efficient amount of items to sell. And when we sell it, we'll have a profit, a maximum profit of $5,090. Again, just matching it all up, let's take a look back at our graph. That's what we found, right? So right here at 1.618, just a little bit above, we had a maximum profit of 5,000. That's our maximum point. We just used a little bit of calculus to get it there. So in conclusion, hopefully you can see how math, and again, here's all the math we used. That's quite a bit, right? We did linear and quadratic functions. We did polynomials. We used the quadratic formula. We looked at our graphs. We thought about slope and derivative. And we used all those math concepts that we've been reviewing in this class week by week. We used them all into getting a business idea, into a business running at its most profitable point. We were able to figure out, okay, sweet. If I make this many items, I'll now know how much to sell those items. I'll now know how much money I'll make in revenue. I know how much it'll cost. And this is how much money I'll make. It's the most profiting point. Now, it's interesting, remember to note in our example that if we only looked at revenue, it would seem like selling the product at $5 and producing 5,000 items would make us the most money. But remember, it actually would lose us money. We would lose $14,000 if we did that. So when you're a business, you have to think about revenue and selling, and you have to think about costs and trying to use math to balance those in the best way possible. All right, so what did we do? What were our objectives? Well, we definitely talked about marginal stuff, cost, return, marginal revenue. We talked about profits, total cost, total revenues. We graphed quadratic functions, we graphed cubic functions, we graphed linear functions. We built a profit function based on the total revenue minus the total cost, and we found the maximum point. It was an optimization problem, and we used math to help us find the best possible solution. Hopefully that was interesting for you. Hopefully you followed along. Again, some of these examples, I'm going to ask you to reproduce or think about these in the lesson quiz, so have this video handy. Have a great week.